Happy Friday, Sharks! In this video, I'm going to cover the odds of a practice quiz on normal distributions. So when we first started talking about normal distributions, we talked about them being a density curve. So as you see in this picture in this first example is a nice density curve. The area under that entire curve is 1 or 100%. And then the first thing we talked about other areas was something called the empirical rule. And the empirical rule says within one standard deviation of the mean, so one standard deviation on either side is 68% of all values. 95% of all values are within 2 standard deviations on either side of the mean. And lastly, 99.7 or almost all of the values will fall within 3 standard deviations of the mean. So in this first example, we are asked, so instructed on 1 and 2 to use empirical rules. So for each question, construct a normal distribution curve and label the horizontal axis with the mean and 3 standard deviations on each side. Then answer each question based on the empirical rule. So no Normalcdf, no inverse normal. I am just looking at empirical rule. So in number 1, we're given the mean life of a tire is 30,000 kilometers. The standard deviation is 2,000 kilometers. So if I label this curve, I'm going to put the mean life, or the 30,000 kilometers, in the center. This is the mean in the middle, 30,000. I'm just going to put the zeros below it to save some space. So that's the mean. If the standard deviation is 2,000, if I go 1 standard deviation above the mean, here I am at 32,000. And if I go another standard deviation above the mean, I'm at 34,000. And if I go a third, I'm up to 36,000. So those are my 3 standard deviations above the mean. Now let's go 3 standard deviations below the mean. So I'm going to subtract 2,000 each time. So here I'll be at 28,000 kilometers, 26,000 kilometers, and 24,000 kilometers. And then I have a few questions here about my sketch. In part A, it says 68% of all tires will have a life between blank kilometers and blank kilometers. Well, empirical rule says 68% will fall within 1 standard deviation. So there's my mean. Here I'm 1 standard deviation below. Here I'm at 1 standard deviation above. So 68% is going to fall between 28,000 kilometers and 32,000 kilometers. I'm still using empirical rule. So next question, part B, is 95% will fall between what 2 distances? And empirical rule tells me, well, 95% of values will fall within 2 standard deviations. So here I am at 26, that's 2 standard deviations below, to 34,000, which is 2 standard deviations above. And C, what percent of tires will have a life that exceeds 26,000 kilometers? Well, here's 26. So exceeding that means I want 26 and onward. So 26 and onward, I'll shade up here. That's from here. And the whole curve after that. So we got to do a little work to figure out that percent. Notice how big this area is here. And I know the whole area is 100%. So rather than figure out this percent, I'm just going to find this percent and then subtract it from 100. And we've done this before. So that's within 2 standard deviations. Let me mark some more things. So I know in green, I know this in green is 95%, right, based on empirical rule. That means there's 5% left over. That means up here is 2.5% and 2.5% on this end. So I can see, either way you look at it, I can add these areas now if I wanted to. 95% plus 2.5%, that'll give me this whole blue area. That's going to be 97.5%. And then part D, last thing, if a company purchased 2,000 tires, how many tires would you expect to last more than 28,000 kilometers? Let me erase my shading here. Said last more, so my shading now, more than 28, 28's here. So I need to figure out this percent. Well, I can use the same rationale as I did before. I know this is 68%. That means what's left over on both sides is 32%. And then I know half of 32, because I only want one of these tails. I know half of 32 is 16%. That means this little guy here is 16%. And 68 plus 16 will give me 84%. But then I gotta go a little bit further because it says a company purchased 2,000 tires. So now I have to multiply. So to find 84% of 2,000, I'm going to do 2,000 times 0.84. And if I do that in the calculator, that gives me 1,680 tires are expected to last more than 28,000 kilometers. So go ahead and try number 2. Pause the video, try number 2. Number 2 is similar. It's also dealing with empirical rule. All right, continuing on with the odds. So number 3, notice the directions have changed. Use normal CDF or inverse normal to solve the following question. So from here on out, we're using the calculator. And I'm going to go with the one that you all have on your computer. And I think if you have your own, you all have 84. So I'm going to use the 84 for all of my calculations as we go along here. But you also have the Inspire when you're in class. All right. So a lineup for tickets at a local concert had an average mean waiting time of 20 minutes with a standard deviation of 4 minutes. What percentage of the people in line waited for more than 28 minutes? So let's sketch a curve. Every one of these, we're going to sketch a curve first. And in the middle of that curve, I'm going to label my mean. So the mean here was 20. And the mean was 20. And the standard deviation was 4. Because I'm using the calculator, I don't have to label my standard deviations. I'm only going to label what we're interested in. And what we're interested in is the percent of people that waited more than 28 minutes. So if 20 is in the middle, that means 28 is somewhere up here above it. I'm going to draw a line and write 28. And then my shading, if it's more, I'm going to shade to the right. So I want this part of the curve. So in my calculator, if I'm given numbers and asked for an area, I want to pick norm CDF. So on an 84, you press second bears, and there is normal CDF. My lower bound, that's how far left the shading goes. So if you look at my question here, the furthest left my shading goes is 28. My upper bound, I shade forever, so that's George Sink. My mean here is 20. And my standard deviation is 4. I press enter and I get 0.023. If I did norm CDF, I'm going to write what I typed in. My answer is 0.023. You can give your answer as a decimal, so that's fine if you leave it as a decimal. Or you can make it into a percent. So if I want to make this into a percent, I move this over twice. That's 2.3%. So 2.3% of people waited in line for more than 28 minutes. B. Move on. If 2,000 ticket buyers were in line, how many of them would expect to wait for less than 16 minutes? So same sketch. I'm just going to redo it. The mean is still 20. The standard deviation is still 4. It's now I'm interested in less than 16 minutes. Well, 16 is to the left of 20. And I shade it to the right or to the left because it's less. So again, I'm going to go to normal CDF. Because I'm asked to find a percent. Second Vairs, normal CDF. My lower bound now is negative infinity, or negative George Sink. My upper bound, the furthest right my shading goes, is 16. And oh look, my mean and standard deviation are still in there from the last problem. And I get 0.159. And again, you can leave your answer as a decimal or you can make it a percent. I'd say I want to make it a percent, that's 15.9%.